Welcome back to the deep dive. Today we're going somewhere that most of you listening, thankfully, probably never have to see.
Yeah, hopefully not.
Right. We are heading out to the tarmac, past the gate agents, past the shiny fuselage, and we are crawling right into the dark, cramped, and frankly pretty terrifying belly of the beast. We're talking about the reality of aerospace maintenance.
And, when you say cramped, you really aren't kidding. We're looking at the heavy industry side of keeping these massive fleets in the air, specifically what happens inside the wing tanks.
Yeah, I was reading through the source material for this deep dive. We've got this stack of technical docs and industry analysis provided by PE Energy. And the phrase that just kept popping up in my head as I was reading was nightmare on repeat.
That's a very fair assessment, I think.
Because for the operations managers running these maintenance, repair, and overhaul shops, the
Yeah.
MROs, it really seems like the job is just this constant battle against physics and time.
It absolutely is. I mean, it's a high-stakes environment where you're juggling volatile fumes, incredibly confined spaces, and a clock that is, literally counting away dollars every single second the plane is sitting on the ground.
So today, our mission is to unpack a very specific piece of technology that actually claims to change the math on all of that. We're looking at the Ram FN EB7325 WT wing tank vent cart.
What a mouthful.
It is. And I know. Vent cart sounds like maybe the most boring thing we could possibly talk about today. It sounds like a glorified fan.
Right. It does sound totally mundane to an outsider. But in this specific world, this fan is the difference between a routine maintenance check and a catastrophic ignition event.
Which is terrifying.
Extremely. Or, on a slightly lighter note, it's the difference between a profit and a loss for the entire quarter.
Okay, so let's set the scene for the listener here. Why is this such a massive headache? I pump gas in my car, I smell the fumes, it's annoying, but I just drive away. What is happening inside a commercial wing tank that makes it so exceptionally dangerous?
Well, you have to scale that up by a factor of 1,000. And then imagine trapping yourself inside the gas tank.
Wow, okay.
Yeah. Fuel tanks and wing cells are what we call confined spaces, but they are incredibly labyrinthine. They have baffles, structural rubs, really strange internal geometries. So when you drain the liquid jet fuel, you do not drain the vapors.
And those vapors, they're heavy, right? They don't just, float away on the breeze.
Exactly. That is the critical physics problem they're up against. Jet fuel vapor is heavier than air. So it sinks, it settles into all the low points, the tight corners, right behind those structural ribs of the wing.
Like water in a basement?
Great analogy.
Yes.
If you just open the access hatch, that vapor isn't going anywhere. It just sits there, basically waiting.
Waiting for what? Like a spark?
A spark, a discharge of static electricity, or honestly, just a technician who needs to take a breath. The environment is highly toxic, and it's potentially explosive. You simply cannot send a human being into that space until that atmosphere is fully cleared out.
So this nightmare on repeat we talked about is basically a plane lands, it needs vital work, but we literally can't touch it because it's a bomb waiting to go off.
Pretty much. And this is exactly where the traditional maintenance methods just completely fall apart. The sources describe what usually happens out there as passive ventilation, or, and this is my personal favorite term for terrifying industrial situations,
Oh boy.
jury-rigged solutions.
Yeah, jury-rigged is great for, I don't know, fixing a lawnmower. Not so much for a $100 million aircraft.
No, definitely not. But the reality is you see it all the time. Crews will set up a standard industrial fan, like something you might see blowing air around a warehouse, and they just point it at the open hatch.
Just hoping for the best.
Right. They hope the ambient air movement will eventually somehow scour out those deep vapors.
But because we just established that the vapors are heavy and they're hiding away in those deep corners.
The air just blows right over the top of them. It's incredibly inefficient. You are essentially waiting for natural diffusion to do the heavy lifting, which takes hours.
Hours of just sitting around.
Exactly. And while that passive process is happening, you have a whole crew of highly paid, highly skilled technicians sitting in the break room, drinking coffee, just waiting for a gas detector to finally beep green.
And that right there is the money down the drain part that the PE Energy docs highlight.
It is a massive financial bleed. In the aviation industry, they rigorously track AOG. That stands for Aircraft on Ground.
Which is a bad thing.
It is the metric that gives airline executives literal ulcers. If the wheels aren't turning, the airline isn't earning. Every single minute of delay cascades through the system.
Right, because you miss your takeoff slot.
You miss your slot Maybe you have to cancel a subsequent flight, you end up paying overtime to the crews, you have to rebook furious passengers.
Hmm.
A delay in just purging a fuel tank can easily cost tens of thousands of dollars in pure operational waste.
And that is assuming nothing goes wrong with the jury rig setup. If you send a guy in there too early because you think it's clear.
Then you are looking at severe health liability for chemical exposure. Or, in the absolute worst case scenario, an ignition. And if you have an ignition event inside a wing tank, you don't just lose the airplane.
So you lose the whole hangar.
You lose the hangar and you lose lives. The stakes could not be higher.
Okay, so the stakes are sufficiently established. We have this heavy, stubborn gas. We have a ticking financial clock and a generic warehouse fan that just isn't doing the job. Enter the Ram FMA EB7325WT. What is this specific piece of equipment actually doing differently? Is the motor just spinning faster?
No, it's not just about raw speed, it's about pressure, and it's about technique. The core engineering concept here is something called a positive purge.
Can you break that down for us? How is a positive purge fundamentally different from just blowing really hard?
Sure. Think of the passive jury rig method like trying to empty a glass bottle full of smoke by just blowing across the open top of it.
Okay, yeah.
You might get some turbulence at the neck, but the thick smoke stays pooled at the bottom. A positive purge is like taking a straw, sticking it all the way down to the bottom of that bottle, and blowing hard. You are physically displacing the volume of air.
Oh, I see. So the ram fan is actively forcing clean air at a high velocity.
High velocity and high pressure. It pushes that clean air into the absolute deepest parts of the tank, which violently forces the heavy, contaminated vapors up and out of the exit points. It is a displacement strategy, not a diffusion strategy.
And the goal there is to drop the concentration levels.
Exactly. The goal is to aggressively drop the atmosphere below the LEL threshold.
LEL being...
Lower explosive limit.
Yeah.
You need to get that vapor concentration down to a mathematical point where it literally cannot burn no matter what. The ram fan is engineered to hit that number fast, and this is the crucial part, to keep it there while people are inside working.
The keep it there part seems really important because I would imagine if you just turn the fan off once it's clear, the vapors could, creep back out of the seals or the insulation?
Yes, that's exactly what happens. The industry term is off-gassing. The physical walls of the fuel tank, the chemical sealants, they actually absorb jet fuel over time.
Like a sponge.
Exactly like a sponge. As soon as you stop ventilating the space, those materials start releasing those trapped vapors back into the ambient air. So you absolutely need a unit that can run continuously, safely, and maintain that positive air pressure the entire time a human being is inside the wing.
And the safely part brings us to the design of the cart itself. The source material from PE Energy really emphasizes that this is an explosion-safe unit, which to me feels like a baseline requirement, but I'm guessing with those jury-rigged setups we talked about, it's not.
You would be shocked. A standard warehouse fan has a traditional motor with carbon brushes, and brushes create tiny microscopic sparks while they run.
Oh, wow.
Right. If you pull combustible fuel vapor through a standard fan motor, you have basically built a jet engine on your hangar floor.
That is a terrifying mental image.
It is. The ram fan avoids this by using completely sealed, explosion-proof components. The actual airflow path where the vapors travel is physically isolated from any potential ignition sources in the motor. It's explicitly designed so that the safety tool itself doesn't accidentally become the hazard.
That makes total sense. Now, another thing that really struck me in the PE Energy notes was the heavy focus on where this thing can actually go. They talk a lot about its portability, because I usually picture heavy industrial equipment being, bolted to the concrete floor, or you have to tow the plane to a specific ventilation bay.
That is the dream scenario for an operations manager, but it is rarely the daily reality. MRO work is chaotic. Sometimes the plane is neatly parked in the hangar, but sometimes it's stuck out on the active tarmac in 90-degree heat.
Or in the freezing rain.
Exactly. Sometimes it's at a remote service bay at a regional airport that wasn't really designed for heavy maintenance in the first place.
So if you rely on a bolted-down system, you're just stuck.
Right. If you can't bring the plane to the fan, you have to bring the fan to the plane. And the EB7325WT is built as a cart. It is highly mobile.
Which changes the workflow completely.
It does. You can roll it across rough tarmac, bounce it over heavy power cables, and right up to the wing. It prevents the entire maintenance workflow from grinding to a halt simply because the aircraft is parked in spot B instead of spot A.
Let's get into the weeds a bit here. The promise of this deep dive is that we look at the actual details that matter. The PE Energy Report highlights a few specific features of this cart that seem really small, like almost boringly small. But they claim these are the huge aha moments for the actual technicians on the ground.
Yeah, the quality of life features.
Exactly. The first one is the power distribution box. Now, to me, looking at the specs, a power strip is a power strip. Why on earth is this getting its own dedicated paragraph in a high-level technical analysis?
Because you have never had to troubleshoot a daisy-chained electrical nightmare at 3 in the morning in the rain.
That is a very fair point. I have not.
In a typical jury-rigged setup, you have extension cords running everywhere. You're plugging into random different wall outlets. Maybe you have a severe voltage drop because the cable run is just too long.
And what happens then?
If the voltage drops, the fan motor slows down, which compromises the purge, or worse, the breaker just trips completely.
And if the breaker trips while a guy is physically inside the fuel tank?
That is an immediate critical safety violation. He has to evacuate the tank immediately. You have to reset everything and start the multi-hour purge process all over again. It's a massive mess.
So the built-in box fixes that.
Right. The Ram fan's power distribution box centralizes everything right on the cart. It properly manages the electrical inputs and outputs. It essentially cleans up that dangerous spaghetti of cables. For a technician on the line, that means you plug it in once and it just works. You aren't forced to play amateur electrician when your actual job is fixing an airplane wing.
It eliminates all those variables.
It entirely removes the "I hope this works" factor from the equation.
Okay, feature number 2 they mentioned, the automatic braking system. Again, sounds like something you'd find on baby stroller. Why does an industrial vent cart need specialized automatic brakes?
Picture this scenario. You are out on the airport ramp. It's incredibly windy. The concrete ground is actually slightly sloped so that rainwater drains away. You have this heavy, solid steel cart on industrial wheels. You turn your back for 5 seconds to grab a ventilation hose.
And the cart decides to take a little walk.
It takes a walk right into the side of a brand new carbon fiber fuselage.
Oh, no.
Now, you haven't just delayed routine maintenance. You have caused major structural damage to the aircraft. You have grounded that specific plane for weeks, maybe months.
Ouch. Yeah, that's a bad day.
The automatic braking system on this cart is dead man style. If you aren't physically gripping the handle and actively moving it, the brakes are locked down hard. It firmly anchors the unit in place. It sounds totally trivial until you're the guy standing in an office explaining to the VP of operations why there's a huge dent in a brand new Boeing 787.
Yeah, that is absolutely not a conversation I would ever want to have. Sorry, boss, the wind blew.
Exactly. It's a fundamental risk mitigation feature. It actively protects the asset.
The third feature that stood out was the modularity, the adjustable mounting straps, and the flexible duct design that lets it fit different aircraft types. This feels like a Swiss Army knife type of argument.
It is, and that versatility is actually crucial for the business side of things. MRO shops rarely ever service just one single type of airplane. You might have a narrow-body Airbus pulled into one bay, a massive wide-body Boeing in another, and a smaller regional Embraer jet parked outside.
And I'm assuming they all have completely different sized access holes in their wings.
Different sizes, different heights off the ground, entirely different access angles. If you buy a highly specialized custom tool that only fits a 737, it's completely useless for half the planes in your fleet.
Right.
The Ram is designed with these adjustable mounting straps and modular ducting specifically so it can interface securely with almost any airframe you throw at it.
Which perfectly transitions us to the part of the show where we talk about the people who actually sign the checks, the procurement teams. Because, let's be honest, they don't really care about straps or dead man brakes. They care about the bottom line. The sources mention this major shift in the industry from buying one-off units to fleet-level buying. What is driving that change in mindset?
One word: predictability. That is the absolute magic word for any operations director. They do not want excitement or surprises on the hangar floor. They want to know, with mathematical certainty, that X amount of work will take exactly Y amount of time.
And if your crews are out there using random warehouse fans and duct tape, you have zero predictability.
Correct. One day the purge process takes 2 hours. The next day it's a bit more humid outside and it takes 6 hours. You simply cannot schedule a multi-million-dollar workforce around that kind of variability. But if you have an engineered, standardized solution like the Ram fan across the board, you finally have reliable data.
So know the exact performance metrics.
Yes. You know that with this specific pressure and this specific airflow, That particular tank will definitely be clear in exactly 45 minutes.
So you can actually build a maintenance schedule that you can stick to.
And that reliability is worth its weight in gold to an airline. It directly means fewer flight cancellations. It means fewer emergency maintenance calls in the middle of the night. It means you aren't forced to pay a third-party emergency hazmat team $5,000 to rush out and do a job your own internal team should be fully capable of doing safely.
There's also the compliance angle to this, right? The dreaded safety audit.
Oh, the person with the clipboard. Yes. Safety officers and federal regulators absolutely love standardization. If you have a different, weird, jury-rigged setup at every single base in your network, you physically cannot write a standard operating procedure, an SOP.
Because the procedure is different everywhere.
Exactly. You can't write step 1, do this specific action. You basically have to write step 1, figure out what equipment you have today, and do your best.
And regulators really hate figure it out.
They despise it. It's an audit nightmare. But with a standardized fleet of identical ram fan units across all your locations, you write one single bulletproof SOP. Connect unit. Engage positive purge. Verify LEL levels are at 0.
It becomes a repeatable science.
It's universally repeatable. And if there ever is a safety incident, you can definitively prove to investigators that you followed the exact manufacturer's procedure. It is legally defensible.
That is a huge point. It's not just a physical tool for the mechanic. It's a legal shield against corporate liability.
Exactly. It takes safety from being this vague, abstract concept and turns it into a hard, documented process.
Now, I want to pivot a bit to the actual supplier mentioned here. The source material we're pulling from is from PE Energy, and they make a pretty aggressive argument in their analysis that you shouldn't just Google vent cart and buy the cheapest one that pops up on a catalog site.
Yeah.
They talk extensively about the massive difference between retail purchasing and forming an industrial partnership. Is that just, slick marketing speak?
It sounds like it on the surface, sure. But in heavy industry, that distinction is very real. Think about the global supply chain for a second. If you are a major airline with maintenance hubs in New York, London, and Dubai, you desperately want the technicians in all 3 of those places using the exact same gear.
Right. You don't want the New York team to be absolute experts on the RAM-MN interface, and then the London team is over there using some completely different machine they just bought at a local hardware store.
Precisely. Because the moment you fragment your equipment, you can no longer share safety training. You can't share operational data. PE Energy focuses entirely on wholesale supply chain integration. They do the heavy vetting up front. They make absolutely sure the equipment is actually rugged enough for the real world, not just what some glossy spec sheet claims it can do.
And what happens when things inevitably break? Because it's heavy industry, things are going to get smashed or wear out.
That is where lifecycle support comes in. If you buy retail from a random website, good luck trying to find a replacement switch or a specific filter for a unit you bought 3 years ago. The manufacturer's probably moved on and changed the model entirely.
Right, they want you to just buy a new one.
Exactly. PE Energy, on the other hand, sets up what they call order continuity plans.
Which means what exactly in practice?
It means they contractually ensure that you can get the exact same spare parts, the exact same filters, and identical backup units 5 or even 10 years from now. They manage all that back-end inventory so the airline doesn't have to build a warehouse just for fan parts.
That makes a lot of sense.
It prevents that classic depressing situation where you walk into a shop and see a boneyard of 5 broken, expensive fans sitting in the corner of the hangar, totally useless, just because nobody can source one specific replacement switch.
Man, that fragmentation is such a massive hidden cost that people just forget about. Having 5 completely different brands of vent carts means you have to stock 5 completely different sets of spare parts.
And you have to spend the hours training your guys on 5 different operating systems. It is a total logistical nightmare. Buying through a dedicated, specialized partner like PE Energy is fundamentally about smoothing out that operational chaos. It's about achieving true scalability.
So if we zoom all the way out here, we started this deep dive looking at the absolute nightmare of the confined fuel tank, the extreme danger to human life, the lost money from grounded planes, the ridiculous inefficiency of passive ventilation. And we've arrived at a highly specific solution that seems to be about way more than just blowing clean air.
It really is. At the end of the day, it's about control. The RAM-FN EB7325-WT literally gives control back to the maintenance team. It firmly controls the toxic atmosphere, it strictly controls the corporate risk, and ultimately it controls the maintenance schedule.
You know, the specific phrase that really stuck with me from the PE Energy notes was calling it an insurance policy.
It is an insurance policy. But usually, Insurance is this grudge purchase. It's something you pay a premium for and just pray you never actually have to use it. This equipment is an active insurance policy that literally pays you back every single day in recovered aircraft uptime.
I think the biggest personal takeaway for me, looking at all these sources, is challenging that really old, stubborn idea that safety equals slow. You know, that classic mindset where safety first usually implies productivity second.
That is the old, outdated mindset, the idea that we have to entirely stop working in order to be safe. This specific type of technology completely flips that script. It suggests that true engineered safety is actually the absolute fastest way to get the work done.
Because you aren't sitting around in a break room waiting for hours. You aren't guessing if the tank is clear. You aren't going back to fix avoidable mistakes.
Exactly. Speed in heavy industry comes directly from predictability. If your safety gear is truly good, it should function like a lubricant for the entire MRO operation. It should make absolutely everything run smoother and faster.
So here's the thought I want to leave you with today as we wrap this up. We know we have a lot of you listening who work in high-stakes, heavy industry environments. Maybe not aerospace specifically, but maybe you're in offshore energy, heavy manufacturing, or large-scale logistics. Take a hard look at your own safety equipment tomorrow. Is it acting as a bottleneck? Is it something your team is constantly trying to work around just to hit their daily quotas?
That is the most critical question any manager can ask. If your team is out there actively fighting against the safety gear, then you bought the wrong gear.
Right. If the safety gear isn't making you faster and more predictable, maybe it's not actually doing its job. Maybe it's just another hurdle. It's a slightly provocative thought. But when you look at the raw financial numbers and safety records on these engineered vent carts, it's really hard to argue with.
The numbers definitely do not lie. Predictability always pays.
Well, on that note, we are going to go ahead and wrap up this deep dive. A huge thank you to PE Energy for providing the technical insights and the hard data for today's topic. And of course, a massive thank you to all of you for listening. It's a very niche, cramped world inside those commercial wing tanks, but hey, it's the work that keeps the rest of us flying safely.
Stay safe out there.
We will see you on the next one.